Hi friends, in this video we're going to discuss about the basics of clutches and brakes. A clutch is a mechanical device which is used to connect and disconnect the source of power from the remaining parts. So the power transfer system will work at the will of the operator. The flow of the mechanical power is controlled by the clutch. So normally in the clutch what will happen is it's going to engage or disengage the source from the driving shaft to the driver shaft. So what are the types of clutches you're going to use? There are two types of clutches you're normally going to use. One is the positive clutch and second one is the frictional clutch. The positive clutches are also called as non-frictional clutches, which purely works on the engagement, and frictional clutches which purely works on the friction between the surfaces. So positive clutch, this is a type of clutch. The engaging clutch surfaces interlock to produce a rigid joint. So they are suitable for situation requiring a simple and rapid disconnection. The engagement surfaces are usually made up of jaw type. So the jaws may be of square type or a spiral type. So they are considering the compressive strength of the material which has to be used for the design. So what are the merits are we going to get from the positive clutches? So it is very simple, no slip will be there and no heat generated, and it is a compact and a low cost. Since it don't have any friction surfaces, so the heat generated will be 0. So you can see the sketch over here. It is a positive clutch where the jaws you can see here. So the engagement can be done using the lever operation. So there is a helical compression spring which engages or disengages the driving shaft with the driver shaft with the driving shaft. So engagement can be done like this, and the jaws will be get interlocked and you'll get the movement. So these jaws either may be a square or a spiral. So frictional clutches, the second type, so it is purely on the frictional forces developing between the two or more surfaces in contact. So frictional clutches are usually preferred over jaw clutch due to the better performance. Since there is a slip in the friction clutches, the merits are the frictional surface can slip during the engagement, which enables the driver to pick up and accelerate the load with a minimum shock. Since there is a slip, so the driver can accelerate or pick up the thing with the maximum load with a minimum shock over there. So they can be used for high engagement speed since they do not have a jaws or teeth. So when you're going to have a jaws or teeth, it has to have a low speed to engage that. Since it is only a frictional one, so you can engage the driver and driven shaft with the high speeds also. Smooth engagement due to the gradual increase in the normal force. So these are the advantages what you want to get of frictional clutches over a positive clutches. So you can see over here driving plate and driven plate. So there will be a friction lining given. So either it may be a one side friction lining or two side. Effectiveness will be there. So it depends on the type of material you're going to use and type of condition you're going to give. Again, there will be engagement, disengagement will be done using the lever mechanism. There is a shaft groove for disengagement of a sleeve, and there will be a compression ring for a return back. So whenever the friction between these two gets, so you're going to have a movement transmission. So you're going to get the movement from a driving to the driven shaft. The frictional clutches either may be a single plate or a multi plate, and there will be a cone type also. So the type of frictional clutches, so the major types what you're going to use single plate or a multi plate. There will be a cone clutch and a centrifugal clutch. So this is a single plate where will be a single plate will be considered for a driven shaft, and we have a single lining of the frictional material with maybe a one side effective or both the side as a effective system. So when both are get in contact, the frictional will get the frictional force. That because of that, the driven shaft will be driven. The second one is a cone clutch. You can see here the cone clutch is a little bit different where you're going to have an angular shape, that is the angle of the shaft. So there will be a frictional lining between both the sides. So due to that friction you're going to get the frictional force and you're going to get the movement. Coming to the third one, that is a centrifugal clutch. The centrifugal clutch works on the centrifugal force normally. So there will be a springs attached over there, and there will be a frictional lining material at the top of the each spring. So the springs will be compressed at the initial stage. When they go for a rotation, because of the rotation and the centrifugal force, the frictional plates come in contact with the outer drum. Because of that, the outer drum, the driven shaft will be driven by the driver. So this is normally used in a 2-stroke and 4-stroke scooters. So if you take an TVS XL, they are going to use the centrifugal drag clutches. So single plate clutch, the single plate frictional clutch consists of two flanges as shown in the figure. Okay, one flange is really fixed into the driving shaft, the while the other while other is free to move along the driven shaft to the spline connection, where you can connect the engagement and disengagement. The actuating force is provided by the spring, which forces the driven flange to the move towards the driving flange. The face of the driven flange is linked with the frictional material as a cork or a leather. So you can see the spiralings and springs, driving shaft. So taper shunt key, so to fix that one into the driving shaft. So if we consider the torque transmitted by the disc clutch, so if I take the diagram, so di is the inner diameter, d0 is the outer diameter, and fa is the auxiliary force acting on that. So if you consider that, there will be a pressure acting, that is P, the pressure intensity of the material. So I want to consider a single element, that is geometrical element. dr is the thickness I want to get, and r will be the radius. So the following notations are used. So d0 outer dia, di is inner dia, p is the pressure intensity, f is the total operating force, and t will be the torque transmitted by the friction. So considering the elemental ring radius r and the radius thickness as dr, so area of the elemental length will be 2 pi r into dr. So 2 pi r will be the circumference into thickness dr. So axial force, that is 2 pi r into p I want to consider. So I want to get the frictional force as 2 pi r into dr, p into mu. Mu will be the frictional coefficient. So coming on to the frictional torque, so 2 pi r dr p mu into r. So total axial force I want to get as going to integrate from Ri to R0 or di by 2 to d0 by 2, 2 pi r dr into p. So torque transmitted by this will be given by T is equals to, again, integration of d1, that is di to d0, 2 pi r square dr into mu p. So this is the basic equation what I want to get for the finding the torque of the clutches.